There might be an object so indestructible, extreme, and brutal that it could kill black holes. Welcome at Tech Space Astro. Let's explore together. Subscribe and like for more space astronomy. Soap bubbles filled with pure energy and with a shell made of the weirdest material that's possible in nature. What do they look like? And are they just a theoretical fever dream, or will they change our understanding of the universe forever? The birth of the most extreme objects in the universe. Very massive stars die in the most dramatic way possible, a supernova. We've explained this process in detail before. But in a nutshell, in less than a second, their cores collapse, crushed under their extreme gravity. The star's shell rushes in, bounces against the collapsing core, and explodes, shining brighter than whole galaxies. Depending on how massive the star was, there are two possible outcomes. Presses into a superdense neutron star, or it kind of breaks reality and collapses into a singularity, an infinitely dense point with no signs or dimensions at all. A place where the laws of the universe stop making sense, and time and space are reversed. Grava stars are a third, even weirder option. Instead of collapsing into an infinitely dense point, the core is kind of ground down, like a rock pulverized to dust by a comet. A cosmic hydraulic press. Atoms and particles are crushed so hard that they transform into pure energy. A sort of mini-universe, if you want. And just like our universe, this bubble violently wants to expand and grow. In a fraction of a second, the bubble smashes into the collapsing star around it. The unspeakable mass of the star collapsing under its own gravity meets the titanic violence of the expanding energy bubble. Like an ancient god hammering on its anvil, a gravastar is trapped between an immovable object and an unstoppable force, forging a new kind of material that we've never seen before, but that we know is physically possible. And then, it suddenly stops. A gravastar is born. What does it look like? Cosmic soap bubbles. Just like black holes, a gravastar can have any mass, but a typical one would be about the size of the London metropolitan area, and as massive as 10 suns. A gravastar is utterly dark, and the coldest thing in the universe, only a billionth of a degree above absolute zero. If we look at it in deep infrared, even the cosmic microwave background glows bright in comparison. How can anything made of matter be that cold? Don't all atoms jiggle back and forth? The thing is, the shell's not made out of atoms. It's made from an entirely new, unique, and extreme matter that doesn't have a name yet, and that's at the very limit of what's physically possible in nature. Actually, the shell is so incredibly thin that atoms seem truly gigantic next to it. And yet, despite being ultra-thin, because it's been forged by two impossibly extreme forces, the shell is incredibly tight. So tight that if you wanted to stretch the whole shell by just 1 meter, you'd need the energy of an entire supernova. What about the inside? Well, it only gets weirder. The interior of a gravastar is perfectly simple, because it's sort of empty. Completely empty. A perfect vacuum without a single atom, particle, or wave. But despite being as empty as it gets, this vacuum is boiling with the most primitive and fundamental kind of energy in the universe. We need a detour to explain how any of this makes sense. The fundamental nothingness at the core of it all. Explain how any of this makes sense. The inside of a gravastar breaks our brains a bit because it's a sort of super condensed nothingness. What does this even mean? We'll have to simplify and use metaphors to make sense of what scientists measure and calculate. According to our current understanding of physics, particles like quarks, electrons, photons, and so on are not really solid objects, but sort of waves in an ocean. In our human world, you can't have waves without water. And in the smallest world, you also can't have particle waves without some kind of underlying, omnipresent cosmic fluid. This fluid is the vacuum, what we perceive as nothingness. It's the fundamental ocean at the bottom of reality. The waves of this vacuum ocean are the particles that make up you and everything else. But even when there are no waves or particles traveling through it, the fluid is still there. And like any fluid we know, it has inherent energy. Vacuum fluid is everywhere in the universe. The room you're in is 99.98% vacuum between the air particles bouncing around. Between the trillions of particles making up your cells, there's vacuum. But it's different inside a grava star. When our star collapsed and condensed so suddenly, it was as if the universe took a cosmic pump and compressed as much vacuum fluid as physics allows into a kind of superdense nothingness. As said before, even without any waves, the nothingness vacuum ocean of the universe has energy. But the superdense vacuum inside a gravastar has almost a billion, trillion times more energy per cubic centimeter than the vacuum outside the star. This is an unbelievable amount of energy and mass, in a tiny space, just like, you may have guessed it, black holes. This intensely compressed vacuum ocean can't be compressed any further. It's at the absolute physical limit of anything that could be squeezed together without breaking physics, like black holes do. The ocean would love to stop being so tight. It wants to stretch out and flow back into the ocean that surrounds the star.